Have you ever looked at a piece of tech and just wondered, how on earth does that actually work? How does a machine think? Well, today, we're not just going to wonder. We are going to crack this thing open piece by piece and really understand the simple ideas behind some seriously complex machines. All right, so let's just dive right in. Take a good look at this picture. At first glance, yeah, it's a jumble of wires, a circuit board, a couple of wheels. It looks like a classic DIY project. But the real question is, what are we really looking at? Is this just a toy, a fun little gadget to build on a weekend? Or is it something more? I'd argue it's the key, a real physical key to understanding how so much of our modern world actually functions, from your smart speaker at home all the way to the rovers exploring Mars. To really get what's going on here, we're going to take it apart, virtually, of course. And, just like any good anatomy lesson, we have to start with the most important part, the brains of the operation. So, look closely, right in the middle. See that blue circuit board? That little thing right there is the robot's brain. It's the command center, the central nervous system that's calling all the shots. Now, the technical name for this brain is a microcontroller, and honestly, it's exactly what it sounds like, a teeny tiny, super focused computer. Unlike the processor in your laptop that's juggling a million things at once, a microcontroller is built to do one specific job and do it really, really well. So what is that job? Well, it's basically a constant four-step loop. It reads instructions we've given it in its code. It pulls in data from its sensors about the world around it. Then, based on all that, it makes a decision. And finally, it sends commands out to the body to get moving. That's pretty much it. Simple, right? But a brain, even a robot brain, can't do much in a vacuum. To make any kind of decision, it needs information. It needs to understand what's happening around it. In other words, it needs senses. Check out the very front of the robot. You can see this little component that kind of looks like a pair of metallic eyes. Well, that's pretty much what it is. This is how our machine sees the world. This is called an ultrasonic sensor. And get this, it doesn't see with light, it sees with sound. Think of a bat flying around in a pitch-black cave. It sends out a little chirp and just listens for the echo. This sensor does the exact same thing. The process is so simple, but it's brilliant. The sensor fires off a pulse of sound that we can't hear, starts a tiny little stopwatch, and just waits. The longer it takes for that echo to bounce back, well, the farther away the object must be. It's a super clever way to map out the world with just sound waves. Okay, so we've got a brain that can think and a sensor that can see, but to actually do anything in the real world, it needs a body to hold it all together, and of course, some muscles to make it move. And that's where the rest of these parts come in. We've got that clear acrylic frame, the chassis, that's its skeleton. And then we've got the motors, which are connected to those bright yellow wheels. Those are its muscles. The job of these parts is pretty straightforward. The chassis gives everything structure, a home for the brain and senses to live on. And the motors, well, they do what motors do best. They take electrical juice from a battery and turn it into pure physical motion. And here's where it all clicks together. The chassis provides the form, the motors get a direct command from the brain, something like, hey, left motor, turn forward. And then the wheels grip the ground to turn that command into actual, real-world movement. So we've met all the players. We have the brain, the senses, and the body. But the real magic, the really cool part, happens when you see how they all cooperate. This is that moment when a pile of parts actually becomes a machine with a purpose. It's this beautiful feedback loop. Okay, follow me here. Step 1. The sensor sees a wall. Step 2. It zaps a signal to the brain that basically says, obstacle, 10 centimeters ahead. Step 3. The brain checks its programming, which says, if an obstacle is less than 15 centimeters away, turn. So it makes the decision. Step 4. It sends a command to the motors to make that turn. And then the whole loop starts all over again. Sense, think, act. That simple sense, think, act loop is the fundamental principle behind almost every single piece of smart technology we use. And that's why understanding a simple robot like this is actually way more important than you might think. This is the real power of do-it-yourself tech. It takes these abstract ideas, like coding and engineering, and makes them real and tangible. It proves that these complex systems aren't magic. They're just simple, understandable parts working together. It completely demystifies technology and shows that anyone, and I mean anyone, can be a builder, an inventor. So let's look at our robot one last time. It's not just a contraption of wires and plastic anymore, is it? It's an idea that's been brought to life. It is proof that with just a few simple building blocks, you can create something that can see its world, think about it, and act on its own. And that leaves us with one last, pretty exciting thought. The parts to build a machine like this are more affordable and easier to get than ever before. The knowledge is all out there, free online. So what really matters isn't just this one robot, but what it represents. If anyone can build the technology of today, what will you create tomorrow?